Can AI help FEA analysts to write engineering codes and input files for analysis? Today I am putting ChatGPT and Gemini to the test by asking them to generate an ABAQUS input file for a uniaxial tension test. Those who don't know me, I have been running this channel for over 5 years, and I have been helping the community by creating videos and tutorials on finite element analysis. Today we will see if AI tools can help engineers save time, or they are just there to confuse us. Let's jump into it. This is the prompt I am going to give today. On the left hand side you can see I have ChatGPT 5 open, and on the right hand side I have Gemini 2.5 Pro. So I have given this prompt: create an ABAQUS input file for a uniaxial test simulation using one element C3D8R, which is a hex element with reduced integration. And I'm going to copy paste the same prompt for Gemini as well. Both are currently working, and you can see clearly Gemini is much faster as compared to GPT-5 because it's taking a long time to think. So as you can see, Gemini is already finished writing while ChatGPT is still going through it. So let's go through the Gemini stuff. So it has given us the whole command, as you see, and it has created a cube of 1 by 1 by 1. It has it says that you can copy the whole input file as a code and then save it as a .inp file. It starts with a heading, gives the description. It has also given us the units, that it has made the dimension units in millimeters, Newton, and megapascals. These are the nodal definitions. And also it gives us that, okay, what is the node ID, X, Y, and Z coordinate. So it looks okay to me from that perspective. And then some other comments which explains, okay, which element it has used and how it has defined the elements. Again, element ID followed by the node numbers are also given to us. Also, it has created node sets to apply loading and boundary conditions, and also the solid section for assigning the material properties. Here it ends the part, and then it goes to the assembly, as you see, and in the assembly it creates assembly, and then it defines the material properties. So here I can see one problem, because in the assembly there is no end assembly command, so it's going to go give some problems. Step definition looks fine. Again, these comments at the end of these numbers with double asterisks are not good in my opinion. ABAQUS in preprocessor will struggle with that, so we will see how it goes. And then these are some comments, and also the boundary conditions in terms of 1, 2, and 3 direction. Again, it has fixed the whole bottom face in all 3 directions, which is not correct for uniaxial test. So I would say I would be careful using this model. But let's say if I don't know anything, I have been given a file, so I should copy it and I should run it. It also explains each and every card, step definition, boundary condition, what it has used, and also the output request it has made for us. So this is how it looks for Gemini. Looks pretty professional, but I'm doubtful about the syntax and also boundary conditions. For ChatGPT, now it's finished, so it has also given us some description of the code, input file. Again, units are given to us. It has used a 10 by 10 by 10 millimeter element, and it has applied a load of 1% strain. So E and nu are the parameters it says we can change. Again, the same thing. The main problem here is the line breaks in between these gaps, and I think input file processor of ABAQUS will struggle with those and will give us error, but we will see. Then it's again the same node definition, then element definitions. Here 3D8R is used here. It says you can use hourglass stiffness as well, but we don't need for the time being for this uniaxial case. Then the material properties, solid section has been created. So you can see in this case it doesn't use this assembly instance parts, while in the other case it was, and I think there you will get an error that there is an end assembly command missing in Gemini code. So again, node sets are created for loading and boundary conditions, and you can see this is much better in my opinion, that it is fixing the bottom face in only one direction, and then it fixes 2 of the planes by fixing the nodes on those planes, that is in 1, 2, and 3 direction. So this way it keeps the lateral faces free, which is usually the case for uniaxial loading. If you're not familiar with how to create this kind of model, check out these videos on the top, and I have discussed in detail how to create uniaxial simulations in ABAQUS using that step by step. Then step definitions comes. Yes, it has mentioned the amplitude function here as well, but which is not needed in this case. We always know that if you use ramp, it's always applies it linearly increasing, so ramp is just that, but it gives us an option that you can have amplitude, so it gives us some flexibility. Then outputs are very much the same. The issue with the outputs, as you can see in this case, it has asked for Gemini has asked for stress and small strains, while the nonlinear geometric option is yes. So this means it should have been asked for logarithmic strains because it's a large deformation problem it has selected, while ChatGPT has asked for both strains, although it has used the small deformation problem, so it will ignore the LE command here. So in a way this looks better, ChatGPT, but again syntaxes are problem. Line gaps, line breaks are really problematic as well in my opinion. Let's now copy these 2 codes and run them one by one in ABAQUS and see what happens. So now I will copy the code from both the files in ABAQUS, and I will name them as unigpt.inp and unigemini.inp, and I will run them one by one. Now time to test. Let's open the ABAQUS command prompt and run these 2 input files one by one. So let's start with Gemini in uniaxial test for simulation file. So I will use this command as you are all familiar with, hopefully, and I'm using double precision and also interactively. I'm running it interactively so I can see on the screen what's happening. So initially, since my ABAQUS is interfaced with Fortran compiler, so it's going to run those checks first, and then it will go to the pre-processing of the data which we have provided in the input to see if everything is fine. and if everything is fine, then it will show standard run, and that means that job is running. If there's a problem in the input file processing, then it will give us an error and it will stop there. So let's see what happens. And you can see there's an error there. So this means we need to go to the .dat file and see where the error is. So here we have in the temp folder the .dat file. So I will open it in the Notepad++ again, and you can see it gives us all the input, and you see the error message. And this error message is the material card is not properly placed. It should be an option of model. And I think this is just coming from the fact that there is an AND assembly command missing. So let me sort that out. So you can see I have put the AND assembly now after the AND instance command. So now the whole loop is complete. And now if I run again, then hopefully it should run without any problems. Also, now we have some more errors, and I think this is just because of the fact that these double static comments are next to the data lines, and I think ABAQUS preprocessor doesn't like it, so we need to move it to the next lines. So we need to create line breaks there as well. So I'll quickly do that so that these things are gone. So you see here, this is the double static comment. For Fortran, C++, maybe it works, but for this ABAQUS thing, it doesn't work right now. So we put it there. We will check next as well. So I'm going to remove all those comments which are in the same line as the data, because that is confusing ABAQUS. So I'm going to do that now. So I think the next one is somewhere here. It's gone. Again, you see it's not straightforward. I mean, Gemini has created a file which doesn't work properly. So if you're not familiar with the syntax, you might be struggling, and you might be spending more time to sort it out. So hopefully now it should work. You see it works. It runs standard and it finishes in no time because it's just one element model. So everything is completed. Now let's look at the results and see how they look like. It should not be proper Uniaxial test, as I told you, because it has fixed the bottom surface in all three directions, and which means there is a gradient of displacements, and lateral surfaces might not be stress-free in its true sense. So it is a Uniaxial test, but it's not actual experimental Uniaxial test in my opinion, because it's over constrained from on one face. But let me show you the result. The file now works and it runs. So you can see it works fine. It shows everything which is doing well. But as one face is fixed, so it will be much wider, or will have the same dimension as the other one. So there will be some resistance coming from the Poisson's effect. And you can see the displacements looks the same, and they should be the same if everything is free. But here you see there is a gradient on one face because this face is fixed, so there is no displacement there in other directions, lateral directions, and that will create lateral faces having some stresses and non-zero stresses, so which is not actually the Uniaxial case. Now let's move to the GPT file and run it. I already told you these line breaks will give us problems first, because ABAQUS doesn't like it when you run the jobs like that. But let me see if it works, because we are doing it in a way that we say we don't know anything about input files, right? So if somebody like me who has no idea about the file, I got the file, I copy it and run it, then let's see what sort of error I'm going. So you see pre-processing the file, pre-exe means like that, and then there are some errors. So again, we will go to the .dat file now and see what is the error message. And I can tell you that error message would be those line breaks problems, and you can see there are like blank lines, and these are blank lines that basically create problem for ABAQUS, because then it cannot link the data lines with each other, right? So we need to remove all those blank lines and then rerun it and see if everything is fine or not. So this is the only issue I see currently in this model. Other than that, the model looks correct to me, and also Uniaxial boundary conditions seems correct to me as well. So just the line breaks we have to remove, as we found in the error, and that should fix everything for us. What I have found is if you copy the whole code and the error message in ChatGPT, it can find the error and it can remove those errors for you and give you a new input file as well. So you can do that as well. In this case, I'm doing it manually because I know what the problem is, but you can try that, and in few iterations you will see your model work. So now the job finished, everything worked fine. Let me open so now I will run it. You see the results are very similar, but direction is different. The loading direction, displacement looks okay because they should be distributed as this, and this is the case. There is no lateral faces, should have no gradients, and you can see if you move in Z or if you move in Y direction now, then you will have no gradient. So this means lateral surfaces are free. So I think this is more accurate way of modeling it. If you look both together, then this is let me bring the Gemini one here, and let's make them the same variable. Let's say U3, they have different directions, so let's compare those. But you see for one, the direction where you're applying the load, it's fine because there's the same pattern, but in the other directions you see there is a gradient as compared to the ChatGPT model. So there will be some lateral stresses because lateral faces are not completely free due to the over constraint in Gemini model. So that's pretty much it. So as you can see, I would rate ChatGPT slightly higher than Gemini. It gives us the right logic behind Uniaxial test. Both were able to create similar sort of input files with some minor issues. And if you're not familiar, you can find the error and you can go back and copy paste the error, and it can sort the error for you and give you the updated file, which after a few iterations should work. The question is would you trust AI to generate models for you? I still doubt it. What do you think? Comment below. And also, if you have tried anything in the past using AI for your modeling, especially finite element analysis, then definitely comment below and we will all learn from you. Please do like the video and subscribe to my channel. Thank you very much.